So today we're going to solve this question, which says if the radius of all arterioles in a group of metabolic active tissue are doubled and mean systematic arterial pressure increases approximately by 50%, what changes in the blood flow to the muscles are you likely to see if the viscosity of the blood remains constant? Also, what happens to the total peripheral resistance and the cardiac output? So, here our data. So, firstly, we have our mean arterial pressure and mean systematic arterial pressure, which is systematic arterial pressure is being increased by 50%. So, meaning the original arterial pressure, which is arterial pressure, and was increased by 50%, was increased by the half of the original, this one. So we are going to add plus 0.5 another arterial pressure, which will result in 1.5 systematic arterial pressure. So this is our systematic arterial pressure. Therefore, we also have the radius, and this is radius. The radius was doubled, so is 2r, the new radius is doubled. And then we also have the viscosity. The viscosity is represented by viscosity. This one is constant, the same as throughout. And also Q represents blood flow. This is our symbols we are going to use, which are standard symbols. Therefore, for this scenario, we are going to use the Pascal's law. We're going to use the Pascal's law. So the Pascal's law states that Pascal's law states that blood flow is equal to pressure, systematic arterial pressure, multiplied by mathematical constant, which is pi, multiplied by radius to the power 4 over 8 viscosity times length. Then this is the Pascal's law. This is the equation for Pascal's law. So for this scenario, what happened is the pressure was increased by 50%. So we are going to say Q is equals to, so the new systematic pressure is now 1.5 pressure, systematic pressure, multiplied by pi. The radius was given to the power 4. So we are going to say the radius is doubled, so it's 2r all to the power 4 over 8, which is just a constant number for Pascal's law. Viscosity constant times length. The viscosity constant are just the same for this one, they are constant, they are not changing. Also the length, we assume that the length is not changing. Therefore, we are going to calculate the new blood flow. So 1.5 pressure, systematic arterial pressure, multiplied by pi, 2 to the power 4 is 16. r to the power 4 of 8 viscosity constant times the length. This is our new blood flow. So I want to see the changes in the blood flow. I'm going to compare this one and this one. So for this one, I'm going to multiply 16 times 1.5. So 16 times 1.5, 16 times 1.5 is 24. So I will get 24. Then comparing with this one, systematic arterial pressure pi r to the power 4 of 8 viscosity constant times length, right, is equals the new blood flow. So I think the difference with this equation, this equation 1 and the equation 2. So the difference now, the blood flow is now increased 20 times. So blood flow is increased 24 times by 24 times. So when blood flow is increased by 24 times, and we want to see what will happen to the cardiac output and total peripheral resistance. So let's move a little bit to the total peripheral resistance. So using using this equation, resistance is equals to 1 over r to the power 4. This equation was brought from resistance is equals to pressure difference. Resistance is equals to viscosity times length over pi r to the power 4. That's our resistance equation. But the issue here is this viscosity constant is constant, it's not changing. The length is not changing. The pi is not changing. So we are going to left with r is equals to 1 over radius to the power 4. And also for here, for the Parseval's law, they also used the same equation. The equation, this one, blood flow is equals to change in pressure over resistance. The resistance is this one. So if you divide pressure, systematic pressure, and this one, you obtaining this Parseval's law. So they drive this Parseval's law to form the resistance. Therefore, so for total peripheral resistance, so total peripheral resistance, and let's say total peripheral resistance, our radius, let's say r is equals to 1, and so total peripheral resistance is equals to 1 over radius. I'll put 1, so I'll obtain total peripheral resistance is 1. And let's say radius is equals to 2, I double the radius. So if I double the radius, what will happen to total peripheral resistance? So resistance is equals to 1 over 2 to the power 4, which is equals to 1 over 16, which is equals to 1 over 16, 1 divided by 16 is equals 0.0625. So the total peripheral resistance is the sum of the resistance from all the arteries, but the resistance for this one is just in an area or a region or a small distance. So this one is just in the small distance, in a small area, in the artery. But the total resistance is now 0.01625. What happens to the resistance? So the resistance decrease by 16 times if radius doubles. Theirs is doubled. Even if I add 4 here, it will decrease by 16 times from 1 to 0.062. So the radius is doubled. What happens to total peripheral resistance? The total peripheral resistance decrease by 16 times. And what will happen to cardiac output? Cardiac output. And in short, and if blood flow is increased by 24 times, cardiac output will also increase by 24 times. In short, if blood flow is increased, cardiac output will also increase. Right? So here we go. So here cardiac output, I want to calculate the cardiac output. So cardiac output is equals to mean arterial pressure divided by total peripheral resistance is equals to mean arterial pressure is equal to 1.5 pressure difference over total peripheral resistance is 0.0625. 1.5 divided by 0.0625 is equals to 24. So what happens is cardiac output increase by 24. So same as blood flow increases 24 times, cardiac output increases also 24 times. So increase in blood flow results in increase in cardiac output. So the systematic arterial pressure is just the same as the mean systematic arterial pressure is also this pressure difference. So in summary, in short, increase in blood flow and result in increase in cardiac output. Result in increase cardiac output, which result in decrease in total peripheral resistance. Thank you.